So I will talk about integration of solar energy by energy storage and flexible sector coupling. I will explain a little bit about that. But let me start with looking at the whole energy system. So in the past, it was very simple. We had fossil fuels. That's a really one-fits-all solution. So fossil fuels really covered our demand here, electricity, mobility, and thermal. It was a centralized system. So I chose these demand sectors because they represent 100% of our final energy demand. So electricity, mobility, and thermal, heat and cold. So today, or in the future, this will change. Now we will have a variety of renewable energy sources. So our supply comes from wind, PV, solar thermal, concentrated solar power, geothermal, bioenergy, whatever. So it's a huge diversity of technology now we're dealing with, and it might be a decentralized system because we have local production, and that really changes the whole picture. And now we have really to think how to really cover our demand in a more specific way. So we need electricity for the power sector. We need electricity or synthetic fuels or hydrogen for the mobility sector. And of course, we need heat and cold for the thermal sector. So looking at these sectors, it's interesting to know that that's a global numbers, to know that the heating and cooling part is by far the largest. So in Germany, it's a very similar picture. I think this holds for all developed countries, more or less, that heating and cooling is a little bit over half of the final energy demand. And then we have transport in the range of 30% and power in the range of 20%. And the interesting thing is that if we look at the share of renewables in each of these demand sectors, we see that the power sector has the highest penetration of renewables. So in Germany, we are here at 60%. But if we look at heating and cooling at the thermal sector, in Germany, we are around about, let's say, 14–15% renewables, and transport, we are in the range of 8%. So globally, you see it's 11 and around about 4%. So that means we have maybe to couple these sectors, but I will come back to that. Actually, in the future and even today's energy system, we need flexibility. And flexibility can be provided by energy storage, of course, also by other measures. But the reason for that is that if we look at the supply side, here that's a PV. If it's a sunny day, it's more or less predictable, but if it's a cloudy day, you have a lot of fluctuation. So fluctuation is the big problem, let's say, to integrate renewables. Even wind, that's a day of a wind power output, even there you have a lot of fluctuations. And then you have fluctuations on the demand side, but they following different rules. So that means energy storage is an approach really suitable to match supply and demand. Of course, you can do other things like demand side management or flexible supply, but as I said, flexible supply is difficult if you talk about renewables. It can come from bioenergy, it can maybe come from hydropower. So, but there are very little possibilities for flexibility in the supply side. So at the moment, I'm leading a coordination group at the International Energy Agency on flexibility of the energy system. And we try to make a kind of definition of flexibility. So we say energy system flexibility is the ability of the integrated energy system to adjust supply and demand to achieve energy balance across all timescales in order to integrate higher shares of renewables. So that is our first approach. So it's quite the same as for the power system, where you have to balance it all the time. And the nice thing in the power system, you have the frequency as a kind of parameter, whether you're successful or not. So we looked at this question of flexibility. We say, if supply matches demand, everything is fine, and if it's not the case, we have to do something. So the first, as I said, could be to adapt the supply, which is difficult. And the last one is to manage the demand. Yeah? We could maybe shift a little bit our demand in time. But there's something in between, and that's here distribution, storage, and transformation. Yeah? The goal is to have the right form of energy, electricity, mobility, or thermal, the right form at the right time at the right place. So therefore you need a grid, the distribution. It can be an electricity grid, it can also be a heat grid, a district heating net. You can have this shift, or you need this shift in time, that's energy storage, and you need probably the shift in the energy form. And now we come to things like power to heat, power to fuel. So you start with electricity and you transform it into another way. So I will come back to something which you will discuss the whole day. So this is now based a little bit on my own experience. So I'm not an early adopter, but since January I have a PV installation on my roof and an electric car. So that's usually you do this because you want to cover your electricity demand. But now you want more flexibility on this very small scale. The first thing, of course, you have a battery in your system. So that gives you a little bit flexibility. But in many cases, it's not enough. You're still losing some of the electricity you produce. So that means the next step could be you start to have a kind of energy management in your home. So your washing machine or your dishwasher runs at times when you have a lot of electricity. Next step could be you integrate your mobility now. And now you step over these sectors from the electricity sector to the mobility sector. You install a wall box and you have an electric vehicle. Now, if this is bidirectional, then it's wonderful because then you can utilize the huge storage capacity in your car. So that's probably 10 times higher than what you have installed in your home. So the next step, that would be a big one. If you go now from electricity to the thermal part, you install a heat pump, and now, very interesting, you could install a heat storage. I will come back to this later. And then finally, or not finally, that's the last thing I could think of, there are many more maybe, is that you start now sharing your electricity with your neighbors. So then you start to have an energy community. So that is not possible in Germany, but interesting, that's possible in Austria, for example. So they have energy communities. Now you start trading between the producers, the local producers and consumers. So that is probably an interesting approach. So now I touched the topic on several points. I will now explain this approach. We call it flexible sector coupling. That's also a result of an International Energy Agency working group. The basic idea is we have in the future renewables from wind and PV as electricity coming into the system. Of course, the electricity sector is, because of that, has a high share of renewables, as I said, 60%. And now we want to couple these sectors in order to decarbonize the thermal sector and the mobility sector. And the flexibility is now, so that's why we call it flexible sector coupling, that we implement energy storage capacities maybe on the demand side. So that allows us to use other storage technologies. We do not have to use, for example, on this pathway to thermal, we do not have to use a battery. It can be a hot water tank, which is much less expensive. So talking about these technologies, we have in general thermal energy storage, electrical energy storage, and what we call chemical. So that's basically hydrogen. Here you see an example in Munich. That's today. You see the Olympic Tower. It's a seasonal hot water storage, 6,000 cubic meters. So it's able to store heat from summer to winter. Battery is clear, hydrogen is clear. So the big difference is that this water storage is very inexpensive. So if you talk about heating demand, it would be probably a good idea to use a thermal storage and not to store it on the electrical side. And of course, hydrogen is the most expensive, but you have a value, let's say, in this mobility sector. Our latest way of visualizing this flexible sector coupling concept looks like this. We have the three sectors, and we have this intermediate layer. These are the storage capacities or let's say the energy carriers. And now you have these pathways. You can go from electricity by a heat pump, that's what we call power to heat, and a thermal storage to the thermal demand. Or you can produce, let's say, hydrogen or other gases by electrolyzers, by electricity, and then supply high-temperature process heat for industrial applications. Or you go from the hydrogen or liquid organic hydrogen carriers, you go to the mobility sector. Or you go directly through a battery to the mobility sector, electric e-mobility. Or you go via a battery, a local battery, to your heat production. Many possibilities, many pathways. So I will show you now 3 examples far away from what you see today, so that it's a little bit different. One is an interesting approach. It's a high-temperature thermal storage. So actually at about 800 degrees, as you can see here, 2 storage blocks, each 35 megawatt hours. It's charged by electricity from wind turbines, actually. It's in the Netherlands. It provides heat to food industry, crisps production, at 250 degrees oil temperature. So you store the electricity, you transform the electricity into heat, store the heat, and then provide it to the process. The next example, you see here always these pathways I introduced to you. So that is, let's say, power to mobility. It's a project in the north of Germany, wind turbines, running to supply electricity for hydrogen production, for electrolyzers, and there is a hydrogen filling station, fuel cell buses and cars used in this area. And the last one is a battery solution. It's a battery solution for fast charging infrastructure. So it's there introduced to supply high power output without upgrading the grid, which is very expensive. And it can also be used for, let's say, mobile charging. So that's the whole topic of the new mobility. I think this is something, a lot of changes in our mind. So probably if there is a rock festival, we might need a lot of charging capacity for a very short time at a specific place. And that can be realized by this technology. So I come to the end of my presentation. The conclusions: the demand-oriented supply is crucial for a fully renewable system. So we cannot rely on this one-fits-all solution as in the past. The sector coupling concept allows to decarbonize all sectors. Flexible sector coupling allows to match supply and demand in time by integrating the storage capacities. And we have a number of technologies available to address this approach, and a number of flexible sector coupling configurations are market ready or under development. So the main message from my side is always think energy storage within real applications, because only then you really can, let's say, quantify the value of energy storage. So I wish you a very successful conference here, and I hope to talk to some of you in the coffee breaks. Thank you very much.